Hey guys, good evening all. Welcome to GATE Conqueror channel. And every day at 7:30 p.m. I'm going to continue giving the lectures in network theory. And here, I have to tell about myself. I'm K. N. Rao. And though I got different public sectors and all, but my experience should speak. Anyway, I got more than 20 years of teaching experience. By 2021, actually, I completed 20 years. And I worked in previously very prominent institutes of offline media, such kind of very good institutes. I worked for a very long time. And here, subjects taken till now. Machines and network theory I'm planning to take, and very soon I'm going to add power systems also. If you want to keep me motivated, like this session, subscribe to this channel. If you want to make me responsible towards your preparation, use my code KNR10 and you will get 10% discount also. And here there are two types of paid platforms in Unacademy. One is Plus, another one is Iconic. And in Plus, you are going to get live classes, rank improvement batches, okay, and crash courses, and weekly tests will be there, doubt solving will be there. All these is going to be Plus, which is subset of Iconic. If you think of Iconic subscription, you are going to get all these, and extra you are going to get many extra things, kind of personal coach. He will guide you. He's an achiever. He will guide you. He will motivate you whenever you are demotivated and all. And he will give you study plan also, study poster course also will be there, personalized test analysis will be there, and also study material they are going to provide. Okay. And then coming to the payment section, if you want to go ahead with the Plus subscription for 12 months by using my code KNR10, 27,225. And for 18 months subscription by using this code, you are going to get for 34,650. And for 2 years subscription, it is going to be 39,600. Now coming to Iconic subscription, for 12 months, you are going to get it for 40,500. And for 24 months, you are going to get it for 54,500. And they thought of increasing the fees from July 1st onwards, but because of huge demand and all, they postponed that. But very soon they may change. So if you want to subscribe soon. And here, Lakshya and Arohan batches. Lakshya batch is meant for GATE ESE 2022, and Arohan batch is meant for GATE ESE 2023. And almost all are very prominent and the best faculties of India. Kind of, this is for ECE, right? This is for electrical. Ankit Goyal sir is there, Aditya Kanwal, Suresh sir. With most of them I worked previously. Okay? And our Vishnu sir is there, Varun Sivasu sir is there. And if you think of ECE also, obviously best faculties are there. As of now, I think best faculties of India are working under Unacademy only, most of them. Now coming to here, this slide, tests. Okay, they are providing some free tests also. They are providing paid tests also. Obviously, paid tests will be more, right? Accelerate, elevate, some kind of tests. Now coming to here, of course, every Sunday they are going to conduct combat. But this Sunday, it is very big. Very big. Okay. And this is going to be like for toppers, top 3 rankers are going to get free subscription completely. And remaining guys also are going to get some percentage of scholarship. And 500 guys, they are going to get 500 kind of surprise gifts. Now here, this is my Unacademy link. You can follow me such that you can get regular updates whenever I'm coming to live, either Plus platform or what is that? Special classes. Okay, either special class or Plus platform. Whenever I'm going to deliver lectures and all, you will get the notification. Just follow that. Next, let us start. First, let me start with 2 problems related to voltage. And after that, we are going to discuss about the contradiction. In our last session, we discussed, right, contradiction between power absorbed, power delivered, and passive sign convention. We are going to link that. Now, see this question. Don't think that this is very basic. Yes, this is very basic, and our target is to strengthen in our basis only such that whenever we go for application-oriented subjects, it will become very easy and doubts will be very much less. Okay. And what is the potential difference between 2 points if it requires 220 microjoules to move 10 microcoulombs from one point to another? See here, I'll give a small recap. Okay. In our previous session, what did we discuss? This is main charge. and this is test charge. For this test charge, some repulsion force will be there, and in order to make it stable there, we have to apply some applied force in opposite direction, which magnitude should be exactly equal to repulsion force, then stable point will come. Now, if I want to move the test charge, from here to here, from position 1 to position 2, I have to, expend energy or not? Yes. We have to expend energy, then only I'll be able to move, because opposite force is there. Beyond opposite force, we have to move our charge from here to here. For that, we have to expend energy. That expended energy per coulomb of charge is nothing but voltage. Okay. So what is voltage here? Expended energy per coulomb of charge. Now go to the question. It will be very easy. What is the potential difference between 2 points if it requires 220 microjoules to move 10 microcoulombs? Potential difference they are asking, meaning that they are asking voltage. So what is voltage here is going to be energy expended per coulomb of charge is going to be 220 microjoules divided by 10 microcoulombs. 22 volts. Right? Of course, as it is, this question will not come in GATE, but we have to strengthen our basics. That's it. Now take this question and assume that this is not given. Assume that that is not given. Because always I say dimensions are more important. Even if you think of ESC descriptive, if you don't mention units, they don't consider that answer or your solution at all. Okay, so units are very much important. Of course, for GATE they will give anyway. Determine work done in moving a 50 microcoulombs of charge to a distance of 50 centimeter in the direction of uniform electric field of 50 kV per meter. Okay, electric field they have given, which is nothing but E, and then charge they have given, 50 microcoulombs of charge they have given, and determine work done, in the sense energy we have to find, and the distance also they have given it as 50 centimeters. Let me go to my previous slide. See here, this distance is 50 centimeter and this electric field strength is 50 kV per meter, and this particular charge magnitude is 50 microcoulomb. Okay. Now let us see from dimensions point of view. If we see from dimensions point of view, we have to find out energy joules. And what is voltage? Voltage is nothing but joules per coulomb. What is electric field intensity? Volts per meter. So volts per meter equal to electric field intensity. Now in order to find out energy, joules per coulomb per meter into coulomb into meter. Problem solved. So my energy here, we have to calculate joules per coulomb per meter is going to be electric field intensity, and this is going to be Q, and this is going to be the distance. Okay, or directly from this formula, if you see, force equal to Q into E, and force multiplied by distance is energy. That's what we discussed. So into distance, that's it. Now it is going to be very easy. 50 microcoulomb and distance of 50 centimeters and 50 kV per meter. Right? -6, -8, -5, -4, -3, -2, 5, 125, 1.25 is the answer. Okay, so energy expended is going to be 1.25 joules. That's it. Now let us enter into our concepts. See, first of all, many students will have this doubt. For DC, for a voltage source or for a voltage, plus minus symbols can be given. But for AC, how to give? Similarly, if you think of for current source, direction can be given to DC. But if you think of AC, for example, if this is the wire, some AC current is flowing through this. What does it mean? My current direction will be for half of the cycle in this direction, for half of the cycle in opposite direction. So how to specify direction? But as per our previous discussion, compulsorily direction should be specified current and polarity should be given for voltage. Otherwise, direction of energy transfer will become unknown. If you don't know the direction of energy transfer, it is going to be foolish, because we can discuss about the analysis of any electrical system later. But first of all, we should know whether to supply energy or whether to absorb energy, electrical form of energy. Okay. Now, see here. If I think of this is voltage source, this is voltage. For example, this particular voltage, if I say 10 volts, what does it mean? Means if I think of this as maybe X, this as Y. With respect to Y, my X is at higher potential of 10 volts. Right? Now for DC we can keep plus minus, but for AC, how to keep plus minus? Because if you don't keep plus minus for a voltage, it is going to be foolishness. We don't know the direction of energy transfer. Now let me think of AC signal. Let me think of this as voltage V. And peak value, let me consider 10 volts. Now, how much is this V? This particular waveform of V can be described as 10 sine omega t. Now, let me represent one voltage source. I am keeping plus minus. Okay, because for AC also plus minus has to be kept. Now see here, if I write like this, can I say this is at higher potential, this is at lower potential? No. I cannot say X is at higher potential with respect to Y, but I can say X is at higher potential of V with respect to Y. Try to understand properly. In mentioning this, of course, some of the guys may keep AC symbol inside, or even frankly speaking, we need not do that also. Okay, means some in order to represent AC, some textbooks will specify symbol like that, means alternating symbol, sinusoid symbol. We need not keep that also as per standard. Okay, now in mentioning this, am I saying X is at higher potential with respect to Y? No. I am saying X is at higher potential of V with respect to Y, and that V value is 10 sin omega t. Problem resolved. Because see here, this particular V value, okay, this particular V value may be at omega t equal to 0 degrees. How much will be this value? Is going to be 0. Okay. Now the same V value at 30 degrees, omega t equal to 30 degrees, it is going to be 5 volts. At omega t equal to 90 degrees, just stay tuned, automatically you will understand. It is going to be 10 volts. Maybe at omega t equal to 270 degrees, it is going to be minus 10 volts. Okay. You will understand slow. Now, X is at higher potential with respect to Y of V. X is at higher potential of V with respect to Y. What is this V value? At 0 degrees, it is going to be 0. At 30 degrees, it is going to be plus 5. At 90 degrees, it is going to be plus 10. At 270 degrees, it is going to be minus 10. Getting a point, right? Kind of. Okay. Let me consider 2 points. Okay. Here at 90 degrees, let me consider. At 270 degrees, let me consider. If we compare these two, it will be sufficient, no? Okay. Now at 90 degrees, let me represent kind of that particular magnitude. So, see here. At 90 degrees instant, this is one instant. Okay. At this particular instant, how much is the voltage? Is going to be 10 volts. Okay. This is related to this one. Now, related to this one, if I see, okay, how much is this particular voltage? Is going to be minus 10 volts, right? Minus 10 volts. So, this is going to be minus 10. Or equivalently, equivalently, I can write it as a. Now see the difference, you will understand. Basically, compulsorily plus minus symbols has to be there. Otherwise, forget about network theory, electrical systems cannot be analyzed. Okay. See here, means at one instant, this is at higher potential, this is at lower potential of 10 volts. At second instant, again upper one is at higher potential and lower one is at lower potential only of minus 10 volts. What is the problem? Okay. Here also, see here, this is X terminal, this is Y terminal. Okay. Now also I am saying X is at higher potential of minus 10 volts with respect to Y. Or we can say Y is at higher potential of plus 10 volts with respect to X. Getting the point, right? So here, these two are equivalent only, no? Maybe minus to plus voltage rise of minus 10 volts. Plus to minus voltage drop of plus 10 volts. Both are same. Both are same. Getting my point, right? Now, this particular minus 10 volts will be provided by your equation V equal to 10 sin omega t. 10 sin omega t. Okay? So, V equal to 10 sin omega t if I write. And if I keep V here. Always X at higher potential only of V with respect to Y, that particular V magnitude can be negative. Okay. Similarly, for current also the same thing. Okay. Means positive magnitude of current may vary. For example, if I think of this is conductor and current is flowing in this direction. If I say I have to show current direction, maybe if that particular current magnitude or current waveform can be sinusoidal, it's okay. It's okay. If I think of this as 5 amperes, maximum value of 5 amperes, and here it is going to minus 5 amperes. At this particular instant, my original current is flowing in this direction of 5 amperes. At this particular instant, my original current is flowing in the same direction of minus 5 amperes. What is the problem? Getting my point, right? So, in both the cases, in first case, current is flowing in this direction, positive current. In the second case, again, current is flowing in the same direction, negative current. Negative current in the sense, positive current is going to be reversed. So, conclusion is very simple. Independent of the type of waveform, it can be triangular, it can be sinusoidal, it can be DC, whatever it may be. Always plus minus symbol should be kept for voltage. Always direction should be specified for current. Okay. Now, let us see power absorbed and delivered concepts and how it is opposing passive sign convention. Okay. See here, our passive sign convention. You will understand because everything is nature only. If you connect this particular thing, our electrical field with our gravitational field, easily we can understand. Then problem will be resolved. Okay. Now passive sign convention and about the contradiction we are going to discuss. If I say voltage, is it done? No, polarities has to be there. Let me write here. Okay. And if I say current here, will it be okay? No. Current direction. Okay. Now what is meant by power? Power is nothing but voltage multiplied by current. But is it power absorbed or power delivered? Power delivered. We have to understand. Okay. Now, my passive sign convention, they say that power absorbed by the element. I repeat, by the element. Power absorbed by the element is nothing but power absorbed by element equal to voltage multiplied by current entering into positive terminal of that voltage. Okay, current entering into positive terminal of that voltage. Okay, fine. Okay, current entering into positive terminal of voltage. Entering into positive terminal of voltage. Now let us see the same thing with respect to already yesterday here in our previous session we discussed about voltage concepts. Now if you compare these two, you will understand the contradiction and then you will get the clarity about the contradiction also. Now see here, if I have main test charge here, main charge here, and our electric field is going to be divergent field like this. Divergent field like this. Okay, and let me take a small test charge here. Small test charge here. Very far away. Already yesterday we discussed, right? Means because of presence of test charge, main charge, electric flux distribution should not be disturbed. In this, magnitude should be less and distance also should be more. Now, means upon this, we know that repulsion force will be there here. And in order to keep test charge there only, we are supposed to apply some applied force in this direction. And when those two magnitudes are same, it is going to be there stable. Now, if I want to move the test charge, okay, if I want to move the test charge from position 1 to position 2 in this direction, should I expend energy or not? Yes. Okay, because opposition force is there. Beyond opposition force, you have to move. Meaning that you are expending energy. Now, let us think of any mass. Okay, so see here, this is the mass. This is the mass. It is ground floor, it is first floor. Okay, from ground floor, in order to move this mass to first floor, I have to expend energy. From first floor, in order to take it back to ground floor, it will deliver energy. Okay, stay tuned because here only the logic will be there. Okay, now means if I'm expending energy, it should go to higher potential, gravitational field. Similarly, I'm expending energy in moving from 1 to 2, so it should be at higher potential, it should be at lower potential. This is voltage. Okay, and in moving from 1 to 2, direction of current is in this direction. In this direction. Now, is it what they say, moving from 1 to 2, you are expending energy. For example, if you move from 2 to 1, if you move from 2 to 1, again upper voltage is same only, lower voltage is same only. If you move current in this direction, okay, if you move your charge in this direction, positive charge, so current direction is going to be in this direction only. No? Then, in moving from 2 to 1, in moving from ground floor to first floor, in moving from ground floor to first floor to ground floor, in moving from first floor to ground floor, it is going to deliver energy. No? Similarly, in moving from 2 to 1, it is going to be delivered energy. Energy will be delivered. Now, if you compare this and this, you will understand one contradiction. What is that? In moving from 2 to 1, see, my current is in this direction and current is entering into positive terminal. Okay, when blue, focus on the blue. When current is entering into positive terminal, energy is being delivered or power is being delivered because rate of energy is not even power. But here I have written power absorbed. Okay, so from here, whenever my current is entering into the positive terminal of the voltage and this particular voltage multiplied by that particular current entering into positive terminal is going to be power absorbed, I said. But here, actually power is being delivered. You understood, right? So power is being delivered. If you move from 2 to 1, power is being delivered. Don't think that kind of electron, proton, some kind of concept. No. Here also positive magnitude of current only. Here also positive magnitude of current only. Okay? And this can be AC or DC. Okay, that particular, that's why I'm using small case letters. Now, if you understand this contradiction, again, our gravitational field. Now, see here, ground floor. If I expend energy, it will go to first floor. Okay, and if I, reduce this potential, it will deliver energy. It is accepted here. Okay, now here, how to understand the contradiction? For example, means this is a stone, rock stone. And this particular rock stone means rock I have taken from ground floor to first floor. I have to expend energy. For example, I have thrown this on top of your head. Okay, if I have thrown this on top of your head will break. Right? Your head will break. Why it's broken? Because delivered energy by this particular rock, stone, delivered energy by the stone is being absorbed by your head. That's why it's broken. Getting my point? Right? So, see here, these are charge carriers, kind of stone. Whatever will be the delivered energy, means if you are moving from plus to minus, your current, in the sense here, delivered energy by the charge carriers is going to be absorbed by your element or system. You understand my point, right? So see here, power absorbed by element. I'm considering this as one element or system, whatever it may be, element equal to power delivered by charge carriers. One time they have to ask this question, I feel, because such a concept will come to limelight if they give one question. If they ask one question like kind of power delivered by charge carriers, then normally people will calculate voltage multiplied by current leaving positive terminal, they will calculate. Okay, but one time they have to give. Anyway, see here, convection is open now, right? Power delivered by charge carriers is nothing but power absorbed by element or system, or power absorbed by charge carriers is nothing but power delivered by the system. Okay, now means conclusion is very simple. Power absorbed by element. Normally we write power absorbed only, but we have to keep it in mind that power absorbed by the element. Power absorbed by the element is nothing but voltage multiplied by current entering into positive terminal, and at the same time power delivered by element equal to voltage multiplied by current leaving positive terminal. That's in our motors and generators. Okay, motors and generators we are going to consider like this. Some back EMF or some EMF or something will be there, and current will consider in this direction. It will be useful for both AC and DC. Okay, it's kind of motor. And if you think of generator, for generator. Okay, anyway, let us start solving one small problem. This is basic question, but as I told you, our basics only should be strong. Try to solve. Total charge accumulated by certain system is as function of time. What total charge is accumulated up to 2 seconds? And what is the maximum charge accumulated in the interval between 0 to 3 seconds? Maximum charge. At what rate charge is being accumulated at t equal to 0.8 seconds? One by one, try to solve. And one thing I'll tell you, without you practicing, you don't get ideas, because whatever the questions we are going to solve in our channel or maybe in Plus or whatever it may be, if you just wait faculty to solve the question, then your mind will not be trained for any new question, because same questions will not come in GATE, no? Different questions will come, and you have to train your mind for a different level of questions. Okay, different questions. Same values they will not give, same question they will not give, no? So the moment you see any new question in GATE examination, your mind should start thinking, meaning that first of all you have to start practicing, right? Even in recorded video also, I request you to pause the video. Okay, pause it here, try to solve yourself and then release. In live anyway, it's okay, because live only, no? Yeah, I got it. Perfect. Now, let us take the first question. That is, what total charge is accumulated up to 2 seconds. This is the conductor. And for this, some system is there. And that system is accumulating charges, kind of capacitor. Okay. And here, my charge flow is with 18 t square minus 2 t to the power of 4. And I'm standing here. And I'm counting the number of charges entering into this. Okay. And at what total charge is being accumulated up to 2 seconds. First of all, at t equal to 0. At t equal to 0, 18 t square, 0, 2 t to the power of 2 t to the power of 4, 0. So net is going to be 0. At t less than 0, we need not, because they did not mention about the at t less than 0 condition. So from t equal to 0, we have to start counting. Okay. Now, Q, they have given 18 t square minus 2 to the power of 4. And in order to have, what they say, how much is the total charge, we have to integrate, right? So this is going to be 18 t cube by 3 minus 2 t to the power of 5 by 5 between 0 to 2. 0 anyway will give you 0 only. So 2 we have to apply. 35.2 coulombs. Let me check how much I got. I didn't calculate. Okay. Anyway, this is going to be for the first question. And now, let us think of second question. See, what is the maximum charge accumulated in the interval of 0 to 3 seconds? What is the maximum charge that is accumulated? Because point here is, see, this is going to be the term for which my charges are going in this direction, and this is negated, right? Negative. In the sense, it is this particular term is indicating the opposite side. Now, at one point, this particular current should be 0. Charge accumulation should be 0. Then maximum charge is being accumulated here. After that point, charge is going to be discharged. Getting a point, right? Now calculate that maximum charge. Q equal to 18 t square minus 2 to the power of 4, and dq by dt maximum is going to be 36t minus t cube should be equated to 0. Maximum value. And this can be 36 minus 8t square equal to 0. Calculate t. 2.12 seconds. At 2.12 seconds, maxima is happening. At that time, how much is the charge accumulation? Q, we have to apply 18 t square minus 2 to the power of 4 at t equal to 2.12 seconds. Is going to be 40.5. Yes. 40.5 coulombs. Okay. Now let us consider third one. If you consider third one, at what rate is charge is being accumulated at t equal to 0.8 seconds? In this is they are asking current. Okay. First of all, Q they have given. Okay, they have given something. Directly, let us do dq by dt is nothing but current. And that particular current at 0.8 seconds they are asking. Okay. So what is meant by dq by dt? Okay. 36t minus 8t cube dq by dt rate, and at t equal to 0.8 seconds is going to be the answer. .7, yes, 24.704. What is this amperes? Okay, and previously in our previous discussion while solving the problem, I didn't mention C. Okay, for coulombs I didn't write C because I was not ready to use, because coulomb is very big term and we got very huge coulombs, no, 40.5 coulombs in our previous, immediately prior to this. Okay, 40.5 coulombs is very big number. That's why I did not write C, but it's okay. And in the next session, we are going to discuss about very beautiful concept. Maybe many guys might think that like they know about what is active, what is passive. Okay, what is active, which deliver energy people feel, right? But nothing can deliver energy, right? So means to understand active, passive, and basic properties and all those we'll discuss in the next session. And thank you guys. Thank you very much. And like our session and subscribe to channel GATE Conqueror.